Yeah, so I'm going to go through the ridiculous RG exploit at a decent pace because I do want to get to state machines at the end. They are amazing. If you haven't seen them before, they're an incredible programming pattern. So, hi everyone, thanks for having me. Uh, let's get started here. So, a tiny bit about me. I love to build stuff, all sorts of stuff. In high school, my friends and I built a large, like 500 square foot mini ramp in my backyard because I grew up in Brandon and the police did not like my hobby at all, and there was no skate park in Brandon, so we built one in my backyard. And then we started pressing our own skateboards too. So we built a concrete mold and found 1/16 of an inch maple veneer, and we do like the multiple plies and everything. And interesting thing about that though is I had to start jacking up against the center beam of my house because I couldn't get enough weight to squeeze the glue out. And at one point, you know those teleposts that hold up your house? That fell down because I took all the weight off of it, and I had this moment where I was like, if my skateboard press falls, my house falls. It's like, anyway, it worked out, but I had a quick panic moment there. I've been doing embedded systems consulting since I was in high school, actually. I just kind of lucked into it. It just kind of fell into my lap, and it was super fun. One of my most memorable projects would be working with this guy. He's George. He's a paintball field operator from Saskatchewan, and we just met online. I was looking at career prospects for what I want to do in university, and I met him online on a paintball forum. And so he was like, hey, I want you to build me this wireless Bassmaster system, and I did, and at the end of it, my mom was really worried. She's like, this is your summer employment, and you don't know this guy. Like, hopefully it works out. I shipped him all the product, and he shipped me back maybe $5,000 in small bills, just like a brick of cash at FedEx. My mom was like, is this legal? And I was like, oh. I claimed it on my taxes. I don't know what he did. But in my current day job, I'm a senior embedded developer for PTX Trimble. I try to make it so that large agricultural machines or robotics don't do a barrel roll. Our current project right now, I do more low-level stuff, but we're working on autonomous self-driving tractors, which is pretty cool. And like I said, I was originally going to talk about state machines, but we're going to pivot quickly here to talk about this crazy MTS thing first. So 15 years ago, I worked for MTS, small internet service provider, mostly creating automated tests for equipment. And before MTS would buy thousands or tens of thousands of like these residential gateways, the group I was in would make sure that they were legit. And just to, I guess, be cool here, I want to share interesting bugs and exploits. I don't want to drag a company's name through the mud, so I've changed the name of a couple of small things here, but everything else is good. So this was one of the residential gateways we were testing, and it's got a whole bunch of Broadcom chips on there, like one for the CPU, Ethernet, ADSL, Wi-Fi, mostly a Broadcom design. Now, we're going to call the manufacturer SuperTech for this, and this was a super fun product to test. And they're a big company. They sell like hundreds of thousands, millions worldwide. And so we weren't expecting to find too much. And now, why was it fun to test? Well, as anyone who's tested any products before knows, if you test a product and you can't find a single thing wrong with it, it's really frustrating. It's like, that's my whole thing. Like, there's no difference between me being on YouTube all day or me trying to find a bug. I didn't have that problem with this device here. We found so many things, I couldn't even talk about it. We'll just talk about the most ridiculous one we found. And this was surprising, though, because this particular residential gateway had already been deployed by Verizon, and so we thought it would be relatively bug-free, it's been carried by the big times. And our project managers were rather annoyed that they didn't really trust us. Like, how could we be finding these crazy bugs when Verizon hasn't yet? So one of the test steps we would use, and we actually built this, we would get like high-end servers, one for each Ethernet or WAN port, and we'd put in Wi-Fi dongles in them, and we could SSH or telnet into these devices, and we would basically do different throughputs different interfaces, and then we could, when we telnet an SSH in, we could run top and graph CPU versus throughput. And it was really interesting, and I'm sure most of you already know, Ethernet to Ethernet traffic, like on your LAN, doesn't touch your CPU at all. But if you go through Wi-Fi or if you go through your WAN, it does have a CPU impact. But as we were finding more and more things, I started digging a little bit deeper, and because they gave us root access, it was easy to browse the file system. And I, at the time, didn't have much experience with embedded Linux. So I was looking around, and there was a webs directory, so I looked in the webs directory, and all those pink HTML pages there I recognized from the GUI, like the top one there, like wizard_wireless.html. But there was a whole bunch of HTML pages I didn't recognize, like these green ones down here. And so I was like, well, why don't I pop one of those file names into my browser bar and see what I get? And what I got was an unsecured Broadcom sample page. This page would allow me to change anything I wanted on the RG, and it had no security at all. And it wasn't just one of these Broadcom pages. There was over 160 pages. So anything I wanted to do on here, I didn't have to be authenticated in this router. I could do anything. And like, so this is the meme that kind of pops up into my head. They have security there, but the 160 other pages allow you to do whatever you want. Now, not everyone in MTS thought this was a big deal. They were thinking like, okay, an attacker would have to be either in your house, like physically connected, or have Wi-Fi access and know your password for Wi-Fi. So what I did is I sent a sample email to one of my coworkers who was always also testing the RG, and we'll just change the name, Gav. Gav didn't have a lot of experience in security at all, and neither did I, but you know, I like stuff, I read stuff, I can use the internet. And I've come across the CSRF attack, so I made a little email, sent it to him, and when he opened it, I changed his Wi-Fi SSID to 8 hertz WAN IP, you know, like juvenile jokes for SSID stuff. And that finally kind of kicked it off, where MTS was like, okay, this is a big deal. We need to push back and make sure this gets fixed. And when I first joined MTS, I was relatively new, like out of university, and I thought, you know, big companies would be very careful with engineering. But time and time again, we would find these crazy, ridiculous bugs. And like if we look at what Supertech was doing, they basically would take a reference design, reference software from Broadcom, drivers in the kernel. Broadcom would provide them sample code, and all Supertech was doing was adding a little bit of customization on top. But they left all of the sample code at the bottom here. And if you've ever written a lot of software, you know usually sample code follows the happy path. It doesn't consider all of the edge cases. It doesn't consider security. And so to have a product that was built on top of sample code was just like, I can't believe this. Like, how is this happening? And so like changing Wi-Fi SSIDs is kind of funny. It could be annoying. You could change their password. But there are lots of ways that you could actually get malicious with this. And DNS is a real-life example. A couple years previous to working with Supertech, we worked with 2Wire. And 2Wire was a great company to work with. They had really good, they also used Broadcom chips, but we found very few bugs with them. They told us a couple years earlier, they had been hit by a massive attack in Mexico, where spammers, or I guess attackers, would send out huge emails that would take control of a 2Wire gateway, RG, poison the DNS for Mexican bank sites, and this would all happen transparently to the user and then direct them to that bank site. So very quickly, they stole lots and lots of Mexicans' bank credentials. And it was even worse because the Mexican ISP, the customization of that 2Wire gateway had no default password. So it's not like someone had to authenticate at all. It was just, if they clicked on that email, they were already compromised. And actually, I think what I've seen through a lot of, my own experiences and other experiences is that Sometimes companies only learn through pain. And 2Wire got dragged through the mud publicly through this one. And probably that might be a good reason as to why when I was encountering their software, it was pretty tight at that point. So hopefully SuperTech has improved their methods. Now, if you're going to apply the same idea today, because this happened a while ago, but I think with product pressures and releases, it'll happen again. Try scanning for hidden sample management pages. Now, those pages, the sample pages, change with the chipset or like the era of the chipset being used. So if you have a device that you are interested in penetration testing, find out which chipset it uses, and that's easy with some of these websites here. You can just look it up. And if the device that you're trying to get into is hard to get root access or source code for, you can look at these, like if you go to one of those websites here, it's super easy to find out, like, okay, if that's the chip I'm interested in, here's 46 other devices that also use that. You can quickly look through those other devices and try to see, like, hey, does one of them have source code because it's GPL, or it's using a lot of GPL? Does one of those devices have telnet? It's easy to get into. So it's there's ways to apply this attack today. All right, so that's the ridiculous, I couldn't believe it example there. Now we're gonna see how much we can get into state machines and security. So first of all, is anyone here familiar with state machines, like the pattern? Okay, all right, I've got some fans, nice. So maybe a third of people. So for everyone else, it's fantastic. It's for me, it was kind of like a paradigm shift of like, wow, this is really, really useful. So a state machine, if you look it up on Wikipedia, it's some blah, blah, blah abstract machine stuff, but really what it is it's either hardware or software. It has states, and it can only be in one state at a time, and it has transitions between states, and it can have actions and code that then run when it's transitioning or when it enters a state. So over here, we have an off state. When you enter this off state, it turns a light off. When it receives the increase event, it goes to another state, and it runs this code here to turn the light on. And we'll actually play with some live examples in a little bit here. Other names you might hear this by are finite state machine, FSM, state chart, state diagram, state pattern. And yeah, I'm actively working on an open source project called StateSmith, which helps solve a lot of problems with making secure and maintainable code. It's not feature complete yet. That probably will take me a couple more years, but it's already very useful. And basically what it does is it takes diagrams, like visual diagrams like draw.io, plant.uml, and other ones, and generates state machine code for you in one of 7 languages. Maybe Go, I think, is coming next. And I'd like to do Rust, but I have to learn Rust first. And even though it's only 2 years old, it's already being used in production in the company I work for, but other IoT devices. If you think of maybe one of the most prestigious vacuum cleaners, they're using it. A safety critical application in France is using it, and also self-driving vehicles in Korea. Not all of them, but one company. Some of the broad places that you can use it for protocols, user interfaces, drivers, embedded firmware, control systems, video games, like shown down here, robotics, workflow processes like ordering and shopping carts, verification, parsers, decoders. You can use them in a lot of different places. Now, without using state machines, here's some kind of common problems you'll see. So we imagine a very simplistic application that's kind of like a getter and setter type of behavior. So when this code, and it's pseudocode, when it receives the event 1, maybe it sets variable x to 10. When it receives event 2, it displays or gets something to show to the user. And typically you have quite a few events. And then the interesting part happens when a new requirement is added. Often the developer is going to follow the existing pattern here, which is basically I get an event and I do something, and I just trust that the events are happening properly. But sometimes you end up with situations like this, and I've seen code like this in firmware drivers where you get an event like upload start, and the code as implemented, sometimes by a junior dev, just follows the pattern and says, okay, when I get that event, I allocate a buffer. When I get the event that the upload is complete, I'm going to use that buffer I already allocated, and then I'm going to free that buffer. Does anyone see any problems with this? No? That's good. That's good. So basically, what if you get multiple upload start messages or multiple complete messages? It's a classic buffer issue. Like you could allocate multiple times, which is basically a memory leak, or you could try to use memory you don't own or free memory you don't own. There's people here smarter than me about how you could actually exploit this. I just know this is bad. Don't do this. And it's easy to spot in this teeny tiny example code here. But in real life, large drivers, you might have 100 different events. You might have thousands of lines of code. And so, it does happen. It's something you have to be aware of. So state machines would fix this problem. There's other ways too, but another place that you'll commonly find issues with statefulness is in user interfaces. I've yet to meet a single front-end developer who uses state machines in their designs. Because usually user interfaces start off very simple, kind of like that getter and setter thing, nothing too complicated. But then sometimes, it evolves, and then they have to add statefulness to their designs. And so often they don't have those state machine muscles or knowledge of how to use it. And so they add a bunch of collection of variables, like is user logged in, or it's actually very, very prominent in early game developer. So if you've ever done basic game development, you'll often you'll run into something like this. Like you have to maintain the state of your character. And so you'll have variables like, are they on the ground, are they crouching, are they falling, are they jumping, attacking if they're dead? And what ends up happening is you get a ton of code where it's nested checks inside of other checks inside of other checks, and it becomes just an absolute nightmare. Using something like StateSmith, this actually generates working code, and you can visually look at everything. If you're a Super Mario and you get hit, you go to small. If you're small and you eat the fire flower, you become Fire Mario. And if in any of those states, because this is a hierarchical state machine, if you get hit by thwomp, you get crushed, you go back to defeated. This is really, really powerful because it's easy for everyone to see. And the other thing that I love about this, whether it's for firmware, websites, or games, is that you're not going from code to writing or creating a diagram so that you can understand what the code is doing. Because as soon as you're manually creating the diagrams to try to understand your code, it begins to rot. Like you get quick requests come in, and so you update the code, your coworkers update the code, and then after a short amount of time, you realize that your diagram is out of date. And as the diagrams get bigger, it can, like one project I was working on, it would take us 2 hours to make sure that the diagram matched the code. And it was just like, that was one of the drivers for creating StateSmith. Now in terms of pen testing, we'll try to get this in quick here. Think of workflows, so password resets, authentication. Actually at the dinner last night, I was talking to people about how they noticed problems with one of their applications with, I think it was password resets workflows where they were susceptible to an issue. Ordering and shopping carts. If you want to attack it, try to visually map the workflow. Visual means everything for thinking about state. It's super duper useful. Attack each point and then look for repeated transitions. Like in my own code review of myself and other people's code, when you have common transitions like this where all of these have a transition to error, usually developers will test 1 or 2 of these. They'll test like this one or this one, and they'll just assume that these other ones work. These are often a cause or a source of bugs. I'll just be quick here. If you're hand coding a state machine and it's small, it's fine. As it gets bigger and bigger, you can end up with a 2,000 line switch statement, which actually starts to become its own security vulnerability. So using tools or libraries can be super duper useful. And yeah, that's where I'll wrap up so we can do some quick questions. I don't want to push the next talk here, but basically StateSmith and state machine libraries can help turn crazy designs like the left into something clean and easy to verify on the right. But yeah, that's it.